Today we're going to be making tables to find a limit. Yesterday we did it graphically. We were looking at the graph and we could see we were checking from the left and from the right. And when we talk about approaching from the left and from the right, from the left or from the right, like coming from the left, so I want to pick numbers that are getting closer and closer and closer, so they're a little bit smaller, a little bit smaller, a little bit less small, a little bit less small, until they get, if I'm coming from the right, it's a little bit bigger, a little less bigger, a little less bigger, until I get to the value. You have to watch out for signs, because remember, when it comes to negative values, if I go -5, -4, -3, -2, -1, 0, 1, 2, 3, blah, blah, blah. Okay, you get what I'm looking at. The bigger the negative, the smaller the value. And so when I'm coming from the left with the negative values, it almost looks like it works in the opposite way. You have to just really watch out for those signs, is what I want you to make sure you do. Watch out for signs. And I'll show you how that works when we get into some of those negatives. But basically what we're going to be doing is, if we are checking from one side, we'll make a table that comes from the left. And so what we're going to do is we're going to have our value, x, and then we'll pick values that are just to the left, like slightly smaller, a little less smaller, a little less smaller. If we're going to be approaching from the right, then we're going to be putting in our table values that are just slightly bigger and even bigger and even bigger than our x value that we're looking for. If I'm checking from both sides, if it doesn't have a little minus or a little plus on that limit, then I have to have this double-sided table. And so I will be going to the right and to the left to fill in my values. And then we're just going to be calculating, and we're going to be looking at our calculations and see if we can find what's happening. So I'll start with this first guy here. This is as x approaches 3. So my x value, I don't want to put that there, my x value, my center value is 3. And then, like I said, I'm going to be checking values to the right and to the left. Now, I want to get close to 3. So putting in things like 4 and 5 aren't very helpful. I want to be just a tiniest bit more than 3. A little less, close to 3. And then a little less close to 3. These are on the to the right of, these are a little bit bigger than. To the left, same thing. I want to be just super close to 3. 2.999. A little less close. A little less close. And what I'm going to be doing is I'm going to be plugging in all of these values. And so I plug in 4 times 2.9 divided by, don't forget to put parentheses around that, 2.9 minus 3. Then I'm going to plug in 2.99. Then I'm going to plug in 2.999. I'm going to plug in 3. I'm going to plug in 3.001, 3.01, and 3.1. I'm not going to do that while you're watching, so I'm going to pause the video, get those values. I urge you to pause and get the values too and compare your answers with me. If there is an issue in your answers, it's how you're plugging it in. And sometimes, again, it's just a matter of making sure that you have the parentheses in the right spot. So I'll meet with you shortly. So I got my values, again, by just plugging in all of these. And what I want to do is I want to be checking, what does it look like is happening from the left as I come in from the left? What does it look like is happening from the right as I come in from the right? So at 3, it turned out to be undefined. There was no value at 3 because it became 3 in the denominator. But when I look as it's approaching 3 from the left, this is x is approaching 3 from the left, it looks like this is getting bigger and bigger and bigger negative. So it looks to me like it's going to negative infinity. If I could do 2.99999, notice every time it looks like there's more nines kind of being added in the center of that, so it's getting really close to negative infinity. If I come in from the other way, it's 124, 1,204, 12,004. Again, I can kind of visualize the same thing. This is getting bigger and bigger and bigger. So x approaches 3 from the right, looks like it's heading towards positive infinity. And remember what we said yesterday when we talked about limits, these two things have to be going to the same place in order for a limit to exist. Well, infinity isn't even a place, and so what's my limit here? It does not exist. So how would I write this? I would say the limit as x approaches 3 of this function does not exist. Okay, so we're kind of, like I said, going to be making tables, plugging in the values, and seeing if we can read the tables, decide what's going on, what does it appear the function is approaching. On our next example, we are only looking at it x approaching 3 from the right. So remember at the beginning that means I only care about the right hand side of 3. Number's just a little bit bigger. So when I make my table, I am going to start at 3, but then I'll get just the tiniest bit bigger, a little bigger than that, and a little bigger than that. And if I can't find the pattern, maybe I need to do more, but usually this should be enough. So I'm coming in from the right. This is from the right. So if I plug in, again, my value here of 3, I will end up at 3 equaling or being undefined. Now I'm going to let you guys again pause the video, fill in the rest of them. I urge you to make sure you're able to do this on your calculators, and then we'll meet back again shortly and then discuss our results. So as I'm coming in from the right hand side, kind of close, I got 10. A little bit closer, I got 100. Even closer, I got 1,000. If I can envision what's going on, if I got a little bit closer, I would be even bigger than 1,000. Where does this look like it's heading? It looks like it's heading to infinity. And so I would say the limit as x approaches 3 on the right hand side of this function, it's approaching infinity. Well, infinity, again, really technically does not exist. So we could argue that this limit as x approaches 3 from the right of the function does not exist because infinity isn't really a location. But we accept both of those answers, and oftentimes we will look at the answer as infinity from the left and from the right as an okay answer, but in general does not exist would be the answer for that one. Okay, so we're going to do the same one. This time we are approaching 0, and so I have to set up from a table, and again this is from both sides, so 0 has to be the center, and then I'm going to go a little bit less than 0 and a little bit more than 0. So a little less than 0, negative 0.001, negative 0.01, negative 0.1, a little more than 0, 0.001, 0.01, and 0.1. And now I need to plug this into my calculator. Please make sure your calculator is in radians in order for you to get a value that works here. If it's not in radians, you're going to come up with some funky things. So please, again, make sure your calculator is in radians. Again, fill in your table, and we'll meet shortly. So first of all, when you are entering these, please make sure that you, again, are in radians. And when you plug in like that first one, it's the sign of parenthesis, negative 0.1, end the parenthesis, and then divide by the negative 0.1. to get your first answer. Make sure that you close that parenthesis, otherwise you're not going to get the correct answers, obviously. But this one, as I plugged in my values, and as long as I keep these sort of following their own kind of pattern, I mean, you can use anything that's really close. I could, put here 0.002 if I wanted to, but like I said, I always like to use a little bit of a pattern, and that way I can kind of even sometimes see a pattern in the numbers, and I was really able to see a pattern in the numbers here. It was 2 9s, and then an 8 3, and then 4 9s, and then an 8 3, and then 6 9s, and then an 8 3. And what I'm envisioning happening as I'm heading this way, the limit as x is approaching 0 on the left-hand side of this function, it looks like it's heading to positive 1, because pretty soon it's going to be 0.999999999999999. You get my gist. Well, for all practical purposes, that's 1. On the other side, it kind of looks like the same thing is happening as I'm coming in from the right. The limit as x approaches 0 from the right of this function looks like it's going to 1 as well. And because these two things are the same, we say the limit as x approaches 0 of this function is 1. We got the same answer on both sides. That's my value. So sometimes we're going to get it to approach infinities, positive infinity, negative infinity, and sometimes we'll get it to approach a value. You just kind of have to be careful. So there are a couple more problems on the back side that we're going to do. There's one more that has a table that you have to make. You're going to be approaching -1 from the left. Like I said, and it's just a normal, typical looking function. Like I said at the beginning, you have to be a little bit careful when you're making your tables with negative numbers, because -1 is what I'm looking at. And again, I want to pick numbers that are just a little bit less than -1. Well, a little bit less than -1 is a little bit more negative, and then a little more negative, and then a little more negative. And so these are sort of backwards of what we'd think, but that's how the negative works. So I'm looking on the left-hand side. Now that we got here, again, please make sure that when you square, you put your negative number in parentheses and square it, and then the top should be in parentheses and the bottom should be in parentheses as well. So again, I'm going to say goodbye to you, and we'll meet back here after we fill in our table. So keep in mind, as I read this, I am reading this as I'm coming towards -1 from the left. I'm approaching -1 from the left. And it appears to me that I get -2.1, -2.01, -2.001. If I envision what continues to happen, the more zeros I add in between this -1 and the end one, -0.0001, -0.0001. If I were to continue that pattern, I would add more zeros in between -2 and the 1 in this value. And so it looks to me like the limit as x is approaching -1 from the left of this function looks to me like it's heading closer and closer and closer to -2. Sometimes the limits are going to be a little more obvious than others, and one problem that's really obvious when you do a limit, I don't even need to make a table for this, but I'm going to anyways, just to kind of go through it. As I fill in on each side of 0, -0.001, -0.01, -0.1, these are my x values. So what do I get when I plug in 0 for x? I don't have an x. This is a constant function. This is a constant function where no matter what, the function is -3. So whatever x is, the value is -3. That's a constant. It's approaching -3. It's approaching -3. It's always -3. What's the limit as x approaches 0 of this function? It's exactly the function. That happens when it's a constant. Again, some are a little more obvious than others. Now, the last types of problems we're going to go through are piecewise functions, and sometimes we get really nervous about a piecewise function. Makes us a little bit uncomfortable, but what is nice about piecewise functions is they break a function into its two parts, and when we're talking about from the left and from the right, we are looking at the two parts of the function. So values less than 4 are to the left, but values greater than 4 are to the right. It doesn't matter that it's greater than or equal to, it just matters that it's the values that work for this function fall to the right of 4. The values that work for the upper piece of the function, this piecewise function, are the values to the left of 4. And so if I'm looking for the limit of this function as x approaches 4 on the right, all I care about is the right-hand piece of the function. So I don't even need to really make a table for this. If I'm looking for the limit of this function as x approaches 4 from the right, all I want to find is the right-hand side. So I want to figure out what the right-hand value of this function is, and I do that by plugging in 4. So this is -4 plus 3, or -1. All I care about is the right. And what's that value? -1. So the limit as x approaches 4 on the right of this function, because again, all I care about is the right-hand piece of the function, is just that particular part, the right-hand side, and that value is -1. That's where it's going. If I look at the next one, I'm interested in the limit as x approaches -5 from the left. Well, here's the left-hand portion, here's the right-hand portion. All I care about is the left-hand portion because it's from the left. So I'll go ahead and plug that -5 in there. -5 squared plus 12 times -5 plus 37. So no real table needed. I just need to figure out what the value is on the left. And so then I'll plug in all that stuff and figure it out. 25 minus 60 plus 37. And I should get 2 for that. And so the limit as x approaches -5 from the left of this function is just the left-hand piece of this function, which came out to be 2 for me. So you might be thinking, okay, that's great for the left and the right because I can see the left-hand part and the right-hand part, but what if I'm interested in both sides? Well, then I compare both sides. And what did we say when we talked about if a function has a limit, it's got to come from the same place or go to the same place on the left and on the right. So it's got to meet at a point. If it doesn't meet at a point, then this limit does not exist. So I'm going to check out the left-hand portion. So the limit as x approaches -2 on the left of this function is the value that I get when I plug in -2 into the left-hand portion. So it'd be the opposite of -2 minus 1. So 2 minus 1 is 1. So that's my left-hand portion. I need to compare that to the right-hand portion. So the limit as x approaches -2 on the right of this function, again, goes into the right-hand portion. That's the opposite of -2 squared, because I'm interested in -2. The opposite of -2 squared, and then minus 1. So this is 4, make it negative. 4 minus 1 is -4 minus 1 is -5, because these two values do not equal each other. They do not meet the way that I want them to. They would have to be the same. The limit as x approaches -2 of this function does not exist. So it does not exist because it doesn't go to the same place on the left and on the right. Again, if I'm just looking from the right, I care about the right-hand portion, the part that's greater than. If I'm looking for the left, I care about the left-hand portion, the part that's less than the point of interest. If I am checking out one, I'm going to check out both sides and see if they land in the same spot. If I don't have a piecewise function, what do I have to do? Well, it's the same function on both sides. So I have to go through and make a table, either from the left, from the right, or both, depending on the problem. Your homework today is 8.2, evens or odds. You're going to be making some tables. Come with questions tomorrow, and we're going to actually practice a little bit more with the tables tomorrow. Have a great day.